Okay, this is just a short video where we will run through ice tables or rice tables, whatever you're going to call them. And basically these are a little device that we would use in A-level chemistry, specifically towards the end of year one and beginning of year two. We would look at using these to help us out when we're considering calculations about the reacting number of moles or whatever. So when you hit these questions, you will be instructed to use an ice table or a rice table, and it will help you really sort of unpick a question and get to the point at which you can just start building up marks. So basically what we're looking at is the acronym RICE or ICE is basically the molar ratio, the initial number of moles, the change in the number of moles, and then the number of moles that we have at the end or at the point of equilibrium. So we have moles of reactants on the left hand side of the arrow and moles of the products on the right hand side of the arrow. So if we look at this very simple example I've used in the first slide, we've got a neutralization reaction with the hydrochloric acid and sodium hydroxide producing sodium chloride and water, and obviously that is a 1 to 1 to 1 to 1 ratio. So what I've done is initially I put in the molar ratio is 1 to 1 to 1, and it would be 1 if I'd included the water. I just haven't included the water in this example. So the question will give you some information, and the question might say we start off with 1.5 moles of the acid, so that's 1.5 moles in this case of the H plus ions, and then 0 moles of the hydroxide ions and 0 moles of salt. So basically we're just starting off with a sample of acid, and the sample of acid contains 1.5 moles of H plus ions. And then the question will just basically, they will give you something that will allow you to work out the rest of the table. So here it said, I've said that we're going to add 1.2 moles of the sodium hydroxide. And as soon as we add 1.2 moles of the sodium hydroxide, that will react with the acid and neutralize 1.2 moles of the H plus ions, because it's a 1 to 1 ratio. So that addition of 1.2 moles of the hydroxide ions will neutralize 1.2 moles of the H plus ions. But when it does that, obviously there will be no moles of OH minus ions left. The hydroxide ions have all gone, they've all been used up. So that's nice and easy. On the right side of the arrow, so the products formed, we would actually form or add or increase the number of moles of salt by 1.2. So it's important to understand that before the arrow, the reactants, the number of moles of reactants will always go down, and then after the arrow, the number of moles of the products will go up, and there would obviously be 1.2 moles of water produced at the same time. And then the remainder of the table, it's just up to you to, complete the simple maths that is there. So we've got 1.5 minus 1.2, so that would give us 0.3. There are no moles of hydroxide ions left. And then the number of moles of salt, well, we start off at 0 and then we add 1.2 moles. So that's basically how we create that ice table. We'll look at one more example, and it's a bit more complicated. Okay, so here's a slightly more complicated example. They don't really get much more difficult than this. Here I've used a generic sort of A plus B equals C type equation, and I've used the molar ratios of 2 to 3 to 4, and I've simplified that down in the rice table as 1 to 1.5 to 2. So the ratios are still the same. 2 to 4 is still 1 to 2, 2 to 3 is still 1 to 1.5. So again, they will just give you data and you just work with the data. So if I say initially I've got 1 mole of A, 2 moles of B, and then no moles of C or 0 moles of C. Here, they haven't given you a change as such in the second row, or well, underneath the initial change. They haven't given you any information about the change row, but they have given you the end or the equilibrium point, and they've done that for A. As long as they give you some information in one of these boxes, you can always fill in the rest. So how do we get from 1 to 0.75? Obviously, we would lose 0.25, so we use up 0.25 moles of A. When we use up 0.25 moles of A, that will react with B in a 1 to 1.5 ratio. So obviously they go down because they're the reactants on the left hand side. So what would happen with C? Well, that would increase, and it would increase in the 1 to 2 ratio that we would see. So the 0.25 moles of A will produce 0.5 moles of C, because again it's the 1 to 2 ratio. 0.25 moles of A are used up to make 0.5 moles of C. And then the rest of the table, you just complete the calculations as normal. So 2 minus 0.375 is obviously 1.625. And then for C, we go from 0 and we add 0.5, so we end up with 0.5.